Thanks very much. Hi, thanks everyone. Can you hear me okay? Mic working good? Okay. Hi, I'm Mark Wunsch. Thanks for having me. First, let me start by saying I'm really humbled by the speakers here at this conference. I'm really excited to be here. It's an amazing group of people. I'm happy to be here in front of you. Thanks for coming. I really appreciate it. My Twitter handle is @MarkWunsch. If at any time during this presentation you get bored and decide to check Twitter, I think I'll be okay with that. Just shoot me a toot, follow me. Do that for me. Thanks. Scaling happiness horizontally. What I mean is, can we eke out performance as measured by happiness by adding new nodes to our system? This is pretty simple, right? Today, I'm going to be talking about the distributed system that I'm most personally invested in, and that's my employer. I work for Gilt Group. We're an e-commerce company based here in New York City. I'm going to be focusing on primarily the technology organization of Gilt. We are a distributed company. And I'll focus on what it actually means to be a distributed company. We decided to optimize for engineer happiness and autonomy. What does that mean to optimize for something like that? How does that look? I'm going to talk about that today. And by the end of this talk, you should have some idea about how we've chosen to construct the Gilt organization and the constraints and trade-offs that appear in the software that we produce as a result of that choice. Gilt engineering is geographically distributed across time zones, continents. We have our main office here in Manhattan, where our engineers are. We also have a few engineers in Portland, Oregon, and then an engineering office in Dublin, Ireland. Smart people all over the planet. And when we talk about distributed companies, this is usually what we think about. But that's not always the case. I think you could be a distributed company and be in one small little office in Soho or something like that. And I hope that becomes more clear as we continue. So today I'm going to talk about the Gilt organization. I'm going to talk about the Gilt application architecture. What is this machine that our organization produced? And finally, I don't think you can talk about the organization without talking about the application architecture. They're kind of one and the same. There's a feedback loop between the two. You can't talk about one of those things without talking about the other. There's an adage called Conway's Law, and it was named after a programmer named Melvin Conway. And it's this: organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. So to put it quickly, any piece of software reflects the organizational structure that produced it. Eric Raymond, who authored The Cathedral and the Bazaar, he writes, if you have 4 groups working on a compiler, you will get a 4-pass compiler. Everybody heard of this? Yeah, pretty common. I might adjust it just slightly. Organizations which design systems are doomed to produce designs which are copies of the communication structures of those organizations. That's probably more apt, given what I think about large companies, or what the general impression of large companies is, that we're forever recreating ourselves in our own image. At the keynote today, Dr. Stelzer said, programs are like people. Isn't that an awful thought? That for all of our neuroses and social awkwardness, that we reflect those back on the programs we create. So in this way, the creation of software is a self-reflexive action. It's recursive. It's a serpent eating its tail. The organization creates the software constrained by the structure of the organization. And that means that in order to affect change in one of those things, we have to change the other. let's talk about Gilt. This is Gilt. As I said before, Gilt is an e-commerce company. We specialize in something called flash sales, which is essentially a sale where we take a limited amount of inventory and for a specific period of time put it up on sale on our site. And typically, our sales begin at noon Eastern time. And the primary technical challenge at Gilt is building this completely dynamic, personalized experience for each of our customers and preparing for this big spike of traffic all at once. So you know, like Black Friday, when you see like images of people smushed against glass at a Walmart. So that's kind of like Gilt, but every day on a website. And it's modeled after sample sales here in New York. We have about 60 engineers, and then other people, designers, UX people, project managers as well. So it's quite a big team. This talk is going to concentrate primarily on the organization and architecture of the customer-facing experience, the user interface. That's where I do my work. But there's a whole lot going on in the back office systems, inventory management, order processing. And they are similar to this, but that's not the focus of this talk. Maybe that's another talk. At Gilt, we live in dread of the monolith. You hear that a lot, monoliths. What's a monolith? Lots of tech companies don't want monolithic architectures. Well, what do they mean when they talk about monoliths? Many companies, when they start out, they start with a certain kind of architecture, and that helps them get to market quickly, but then they start to feel the pain of that system as their company needs to grow. And for many companies, and for many people, it takes the form of a simple Rails application, right? It's probably old, running an old version of Rails, and it's running Mongrel or Passenger, like some system that you don't even know, like it's not documented anymore. It's end of life 2 years ago. And maybe for some of you, it's a Django application or it's a Spring application. But generally, your organization started with something, and now you've outlived it. And at Gilt, our Rails application is the golden calf we built, and we're forever in absolution. And we've moved past our Rails application to a microservice architecture, and we've moved onto the JVM, but still looming in the background is our Rails application. What is it about so-called monoliths that prevent you or hinder you from growing your company? And I'm not talking about like the Rails doesn't scale meme. I'm talking about a different kind of scale. And when we talk about scale, and when we talk about Rails, we always talk about a shared nothing architecture. Isn't this amazing? This is what allows us to scale horizontally. You add new nodes to the system, and you turn it on, and it scales right up. And we use the term sharding to describe this behavior, and sharding sounds awfully a lot like a bodily function. Shards, of course, are the secret ingredient in web scale sauce, and we want our company to be web scale. But this is a myth. Something is shared. And I'm not talking about the database. We share resources. Now, if you're not well-versed in management speak, resources means people. It means human beings. We need resources to build the features in our products for our customers. And resources, I use cynical air quotes, because it's not a great way of framing things, because it treats people and engineers as fungible. They're capable of mutual substitution. And I think as engineers in the room, we all know that that is a load of crap. So these are the resources we need to make a feature for Gilt.com. We must have at least one of each resource. And these are job titles for people. And you can really tell a lot about a person by a job title. What if you don't have enough resources? What if Felix is the only backend engineer who understands how the code that does discounts work? He's the only guy who knows that, but he's working on a different project. What happens if Chris is the only front-end engineer who really understands the login and registration flow, but he's so burnt out on it. He doesn't want to work on that anymore. Or what if you have a visual designer and a project manager who hate each other, who just don't want to work with each other? So all of a sudden, you have all of these constraints on the resources you want to use. What if you've assigned all of these resources to projects, and you feel really good about yourself, but then the business says, actually, we want to do something else. We've changed our minds. We've changed the strategy. This is a concurrency problem. And I think where most companies find themselves at this stage in their growth is in deadlock. You can't get a resource. You can't get access to it. Sometimes the resource, the engineer, is unable to do the work they need to do. They're locked on something. And what ends up happening in this scenario is that management, effectively just becomes thread schedulers, trying to figure out where to allocate the right threads. And this is how Gilt worked for a time. I think this is where a lot of companies in growing pains feel themselves. And every week or so, we had this meeting with a funny name, and you can ask me what the name of the meeting was later. But we looked at business requirements and the spreadsheets of all the different people and all of the different job titles we needed in order to get work done, to put our resources. And things change and move in priority, and they take longer than you expect. It's a concurrency problem. And I'm going to assume everybody here is familiar with the dining philosopher's problem. If not, it's on Wikipedia. It's got a good explanation. But this is the situation that your company gets in. Right? A developer is a philosopher. They can either eat or code and read Stack Overflow. That's the two things that they can do. But in order to eat, they must obtain the requirements and the deploy bit. Right? 2 forks or 2 chopsticks, depending on your impression. So the resources that an engineer needs to obtain in order to do their work, to write code, can be a lot of things. It can be the code base. It can be business requirements. But an engineer who starves, who can't write code, is unhappy. That's a good assumption to make. And an engineer who can do nothing but eat and can't stop and think and read Stack Overflow, hopefully not Hacker News. We should stay away from that. But that engineer is unhappy. And so what I think about when we talk about monoliths, we're really talking about a mutex, an organizational lock. There's some lock that prevents an engineer from doing work. And that monolith can be the software itself, like the Rails application that just grew and grew and grew. Or it can be a person, the chief architect that wants all of the patches emailed to him. Typically, it's the organization itself. The organization puts constraints on the engineers that don't allow them to do work. When a bug is introduced in your code, what do? You do a thread dump. You figure out, where did this bug get introduced? What happens when a bug happens in your organization? You have to take a thread dump. You have to figure out what engineer was assigned to what project, what engineer was on which feature. It's a mess. The sleeping barber problem is also another great concurrency problem. It's on Wikipedia. You can implement these things. It's fun. So in this scenario, right, our business, Gilt, spawns these customers. And the customer comes to the engineering organization, who might be asleep. And they have to figure out how to wake it up. And the engineering organization can only cut one head at a time. And who knows how they get to the waiting room or not. These are these concurrency problems that happen within our organization that we have to deal with. So what do we want? We desire a highly concurrent, distributed, and fault-tolerant organization. We want our organization to be these things, highly concurrent, that business value is derived simultaneously. We reduce locking. Locks are people. Locks are software. If a person is free to work without locks, that makes them happy. Distributed. The work is partitioned across nodes. The organization itself can be sharded. Fault tolerant. That means the organization can continue working in the event of an organizational failure. What's that mean? Well, like Felix, the guy who knows about discount codes, he gets a great offer to become a CTO at a startup. It's good for him, but that's a fault. Now we have to recover from that failure. Chris should be allowed to work on code other than login and registration. Our CTO should be able to go on vacation. Being a fault-tolerant organization means that you allow for engineers to move and to express themselves. And this is how we scale happiness. So how do we build a highly concurrent, distributed, fault-tolerant technical organization? So at Gilt, this is the approach we took. Teams, ingredients, initiatives, and KPIs. And we wrote a blog post about it, and there's a link there. And I'll make sure that these slides get shared so you can read the blog post. But it's really good, and I encourage you to read it. And it was based on a similar paper by Spotify about their agile process. So these represent the primitives of our organization. We're going to design an organizational blueprint that shows how we work. Initiatives and KPIs. So initiative is a project we expect to work on for the foreseeable future. And that could be a quarter, it could be a year, it could be whenever. But it's the business strategy, or one part of the business strategy, that the engineering team must execute on. And initiatives are defined in terms of KPIs, or key performance indicators. In your software, hopefully, you measure everything. You know the numbers about how your software works. Why wouldn't you do the same for your organization? You must have numbers to show where your organization executes on its initiatives. Mission statements are anti-patterns. Gilt's going to be great at selling clothes. Yay. It's simply a more subjective and less useful denormalization of a metric. Teams and ingredients. So in our distributed company, in our distributed system, teams are the nodes. And teams work on initiatives, plural, maybe, but they outlive initiatives. And teams are focused, they pick what they want to work on, and they are autonomous. They're a small startup unto themselves. They're like self-organizing, self-prioritizing workers. There's no business owners, right? Some external entity that says, what are you guys working on today? Because ownership is an anti-pattern. Because it implies disempowerment of the team members who are not owners themselves. Teams are organizationally flat and cross-functional. So in order for a team to do what it needs to do, it needs ingredients. So what are ingredients? That's someone like a product visionary, or someone who's a great writer, a great communicator, or a business thinker, or a data analyst, or a coder, heads-down coder, an architect. These aren't job titles. These are people with focus on specific areas to help their team succeed. To a certain extent, job titles are anti-patterns. Because as an engineer, or as a UX designer, or as a QA engineer, you allow yourself to be defined by your job title. That's not my job. It's a really easy thing to say. But that doesn't help determine what you hope to contribute to your team, or what you hope to contribute to the company, or what you want to learn. So this is a diagram of our organizational architecture. This is how our organization looks. And it implies certain things I'll talk about later, but this is what we want. We want to build this team, or this way of working. Now, how are the teams tied together? How do they communicate? What's the protocol that they use? So this talk that I'm giving is really heavily inspired by one that Coda Hale gave at Etsy. Coda is a really brilliant architect, brilliant thinker. And he talks in that talk about hive minds and pen pals as this spectrum of communication styles. And so on the one, you have hive minds, who are these tightly coupled units who communicate through informal APIs. There's very little modularity. This is a monolith, what we think about when we think about monoliths. And they value immediate productivity over long-term maintenance. And so most really small startups sort of communicate as hive minds. And on the other end of the spectrum are pen pals, who are divergent in terms of both geography and organization. There's formal APIs and very loose coupling and formal documentation, and maybe they don't even like each other all that much. They value limiting the scope of potential change. So this is a spectrum. And architecture and software play a role in this spectrum. So knowing the organization we want to create, how do we steer our software to help us communicate in a way that makes us feel productive and efficient? So given how we want to work, how do we enforce it, in other words? And we know from Conway's law that the only way to reinforce, to sort of support the communication structure we want is by architecting our software to support it. And we built an application architecture to support our organization. And we call that architecture LOSA. So we have to make a decision about which communication structure works best for our people, knowing our people, given our geographically distributed nature. And based on our experience with locks, we desire team autonomy and independence. We desire loose coupling. And we have to consciously design software to allow our teams to work in this way. So what's LOSA mean? It means lots of small applications. For lots of small applications, for lots of small teams. And in order to reduce the amount of these organizational locks a team has to deal with, in order for teams to remain autonomous, each team owns and operates N applications, each under their ownership. So some of you, I don't know everybody's background, but some of you might be shuddering at the thought of this. Huge amounts of applications. Maybe you're totally into it. That's cool too. So there are lots of teams operating independently on their initiatives, and each one maybe gets their own application. And Gilt itself is composed of these applications. So this is complex. This architecture introduces lots of complexity at both the software and the organizational levels. And it implies some constraints. It's an opinionated architecture. So why did we choose this? Why did we say, every team gets an application, go for it? Well, what do we know about distributed systems that we can apply to our organization? Well, we know what they're not. These are the fallacies of distributed computing. I crossed out computing, and I wrote organization. And it works just as well. So fallacies of distributed computing. Number one, the network is reliable. This is a fallacy, right? Can any of you who work at a larger company say that the communication network in your company is reliable? Or that latency is 0? Or that bandwidth is infinite, right? If only our company's bandwidth was infinite. These all apply just as well to your organization. So how does LOSA work in the face of these constraints? Or put another way, how does LOSA allow us to embrace these constraints? Let's talk about CAP theorem. I hope everybody at the Distributed Systems Conference is familiar with CAP theorem. So we can only choose 2 of these. We know that. Can we apply CAP theorem to our organization? So just a refresher, consistency, all nodes see the same data at the same time. Availability, a guarantee that every request receives a response about whether it was successful or failed. And partition tolerance, the system continues to operate despite arbitrary message loss or failure of part of the system. So which 2 do we choose? Well, we actually know that that's not really true. We have to choose partition tolerance. Right? There's a great blog post, also by Coda Hale. I really hope everybody in this room has read it. You cannot sacrifice partition tolerance. And that actually works the same way in your organization. Like, what if there's a bank holiday in Ireland? Our network partitions. Right? We don't have access to those guys anymore. What if a team decides that they really need to get heads down, so they decide to do an off-site hackathon or something for a week. Right? We have to be able to be resilient to that. So we have to choose partition tolerance. So now we have to make a trade-off. We have to choose between consistency and availability for our organization. So what are our requirements? We desire autonomous nodes that can produce meaningful work on initiatives without external monitoring or ownership. So it should be apparent, based on those requirements, that we chose availability. We sacrificed consistency in our organization. LOSA and our organizational approach is a decentralized peer-to-peer network. This is what Gilt looks like. The nodes in our system, which are our teams, communicate ad hoc. So they sometimes share with the other nodes when they have similar work, but not always. In this way, when the network partitions, which it will, both in the organization and the software, you always get a response. So the teams are like these small little hive minds that communicate in the fashion of pen pals. And in that way, Gilt is like an incubator. Right? Gilt just sort of owns and sort of like observes these small little teams working. So how do they communicate? How do we communicate? We use code review, automated code review. Code review is the preferred mechanism of communication between our teams, between our nodes. Because there's email, and there's Google Groups, and there's chat, and there's collaborative documentation, and God forbid you even have an occasional meeting. But what's really amazing is code review. And we use Garrett for code review. I don't know what the stupid little bird is, but maybe you use GitHub. But automated code review is the most important communication tool for our organization, and I think it's incredible. Because what code review gives you is a permalink. You get a URL to a discussion and a decision that resulted from that discussion. So this code was either merged or it wasn't, or someone didn't like it and it's just been waiting forever. Code review should be everywhere in the organization. It's such a powerful tool. So what does this mean for Gilt to be inconsistent or to sacrifice consistency? Well, it manifests itself. It presents itself in the user interface for Gilt. So I don't know if you can tell this, but these two little toolbars are different. One has like a little bell icon, and the other one doesn't. This is inconsistency at work. So these are two different applications, and there's a user interface library that's shared between them. And one is a version above the other. So sometimes features or teams require or demand consistency. And then they need to wait. They need to wait on a lock, right? Some engineer to review that Garrett patch. And in our distributed architecture, because we've chosen availability over consistency, it's kind of hard to swim against that current. And it's not easy. So a user interface library is shared between these two applications. So that means that so much of LOSA is managing dependencies. Managing dependencies is so hard. Is our app up to date with the latest version of the whatever? And what does that whatever depend on? So in this case, this is fine, right? This is such a small little user interface inconsistency. But what we're really saying is it's OK for the user experience of Gilt.com to be inconsistent as users navigate from application to application, from the domain of one team to another. Dependency management is really hard. And were we to choose consistency over availability, it might not be something we would have to worry about. But then, if we were to do that, we would have these locking mechanisms, and we weren't comfortable with that. So in many ways, Gilt Tech itself has become like this small open source community. And shared libraries and practices emerge from these nodes, but they're not always followed strictly. So, right, sometimes people do things that you don't expect. And sometimes they conflict. Two teams might have two different solutions for the same problem. But that's OK, because the cream should rise to the top. You hope that the very best of what these teams do is shared. And in that way, Gilt is eventually consistent. And some teams focus on application engineering, but other teams build libraries. It depends on what the team feels is the best use of their time. And these shared tools that those teams build have to be fantastic. They have to be great. Because otherwise, they just won't be used. If you dip your toe into the waters of open source, and you'll see that there's so many solutions to the same problem. You pick the one that's best. So Ryan Tomeko is one of the early engineers at GitHub. And GitHub is a really interesting story because, of course, GitHub uses GitHub to build GitHub. And so he writes a lot about using open source processes in your company's organization. And this works really well for us. And sometimes there's consistency enforced by the other nodes. So in that way, it's almost, there's like a quorum happening between teams. So if my team decides that I'm going to build my small application, and it's going to be entirely in CoffeeScript and Node.js, the other teams are going to be like, what are you, crazy? That's nuts. That's not how we do things. So over time, the nodes have sort of converged on what works best for us. But the important thing is that it gets sorted out in time. And that doesn't work for everybody. It probably doesn't work for a company like Apple. They probably value consistency over availability. Or if you're a small stage startup, you probably value consistency over availability. It also places a demand on teams and their engineers. So we need the engineers who work for us and work on these teams to be entrepreneurial. And they need to become technology evangelists. So because they have to push their agendas to other teams to make sure that they succeed. And that's not for everybody. Not everybody wants to do that. And that's fine. Earlier, I said at Gilt we optimize for engineering happiness. So notice I didn't say we guarantee engineering happiness, right? It's just not for everyone. The point is, you always make a trade-off. LOSA is this application architecture that we built, and we designed its requirements based almost entirely on our organizational architecture. The organization and the software feed off each other. And if we want to make changes in our organization to optimize for happiness, as the organization grows, we had to make changes in our software, in the architecture of our product. So we needed to reduce locking and waiting so that our engineers could feel productive and empowered as teams grew. And you have to make trade-offs to accomplish that. So apply the same rigor to your organization as you do to distributed computing. The trade-offs and constraints you will encounter when doing distributed systems computing are awfully similar to the ones when you're building teams of people. If there is a fundamental software problem, we built a monolith, oh, Rails doesn't scale, maybe the organization is locked on something in that software. If there's an organizational problem, like there's a process, like I'm so sick of filling in my TPS reports, is there something in the software that is making people feel stuck on the process? This is how we scale happiness, by consciously making a change to our application architecture to benefit our organization. Thanks very much.